life on our planet is only possible thanks to the sun's energy. Without it, the Earth would be a snowball at 180 degrees centigrade below zero. The sun is extremely dynamic, active and full of structures. From the corona, the outermost region of the sun, the solar wind flows away, a continuous emission of high-speed particles. It includes protons, electrons and helium nuclei that propagate our star's magnetic field. The first signs of the existence of the solar wind emerged from observations of comet tails pointing in the opposite direction from the sun. In 1958, the American astronomer Eugene Parker was the first scientist that gave a satisfactory explanation for this phenomenon, although another 4 years were to pass until the Mariner 2 spacecraft confirmed it. The solar wind is shaken by storms that burst thousands of millions of tons of material out into space in just a few hours. These are called coronal mass ejections. Their frequency changes with the 11-year solar cycle of magnetic activity. The direct impact of these particles on the Earth's surface would have a serious effect on life. Fortunately, our planet is protected by a shield or magnetic screen. Only the polar zones lie outside this protection, and this results in the colourful aurora borealis and australis. We can use the following simple example to understand this phenomenon. Let us imagine the Earth like a car we are driving along the road. We could compare a coronal mass ejection from the sun with a sudden gust of headwind that would blow all the air out of the car. The resulting vacuum would then be occupied by that wind, but it would fill it up from the rear of the car to the front. The subatomic particles of the solar wind also reach the Earth's poles in a similar way, and then produce this marvellous sight. Other phenomena in the universe yield similar flows of particles. Violent events such as the explosion of supernovas eject even more energetic flows of particles than the solar ones. They are known as cosmic rays. These were first detected by the Austrian scientist Victor Hess while measuring the increase in the ionization of the air with altitude during an ascent in a balloon. In this case, our protective shield is the sun itself, by means of its magnetic field, spread out by the solar wind, producing a bubble called the heliosphere. This is only partial protection, and some rays hit the Earth's surface. In the future, when the human race starts the exploration of our planetary system, the space weather forecast will be as important as a weather forecast in the terrestrial atmosphere is nowadays. In fact, even now this prediction is invaluable for the correct operation of our communication satellites, GPS and other navigation systems.